Maple TA Lesson 12B, homework question number 4. The table below shows which hand is favored by each person from a sample of 100 people, 50 male and 50 female. Use the information in the table to answer the following questions. We have male and female, left-handed and right-handed, 32, 8, 18, and 42. I've thrown this into Excel just because, and it'll be easier to find some of these out. The first thing I want to do is find some sums here because I saw that we're going to be finding some probabilities of male and female and left-handedness and right-handedness. So I'm going to add these two together. Oh, we don't want to percent. That's from previous example that had that formatted as a percent. There we go. And then we want some sums over here. Sum of male and female. This should match our 50 male and 50 female, but let's just throw it in here just because. Yep, it matches, and this, which tells me the total number of people. I can add this together, or I can just do that in my head. Okay, now it asks me to determine the probability that a randomly selected person from this sample will be female or left-handed. That means I want to find all of the females here and all of the left-handed people here and add them together, which gives me 90 people, except that 8 of these overlap because, as you see in the total here, I added the 8 here and I added it here, which means I've added this 8 into that total 2 times. So I need to do my 40 plus 50, but I need to subtract that 8 because it was added in twice, and we only want it once. So we're going to do equals 40 plus 50. Don't forget to subtract where they overlap, and we have 82. Now I'm going to take this 82 and let's come here. We'll do 82 divided by our total, in this case 100, which makes it 82%. All right, now we want to find a 95% confidence interval for the true proportion of the population that is left-handed. So here's our left-handedness here, 40 out of 100. And if we wanted to find that percentage, we would do 40 divided by 100. In fact, let's do it over here. We'll do, oh, I'm sorry. Yep, I think that'll be okay. We'll do percentage of, oh, that was male and female. I want percentage of the left-handedness, so I'm going to delete this. I apologize. I don't usually try to delete my work. We're going to do it here for left-handedness, and we want it for right-handedness as well. So we're going to get our percentages here. Now, these ones are easy to calculate in my head, but those of you who might have different numbers, then I'm showing you how you would find this. So we're going to find our sample statistic, or the percentage that we're dealing with or worrying about. And I didn't absolute cell reference the 100, so we will not click and drag. We will have to do this. All right, so we have 40% and 60%. To find the left-handedness, we need to find the low and the high with the margin of error. So our margin of error is calculated, remember, 1 divided by squirt, or square root, to help remember. The square root stands for total, and in my study there's 100 people, so it's divided by the total of 100, or the square root of 100. Okay, so we have 0.1, and so my low will take this left-handed, and then we're going to subtract my margin of error, and then we'll take our right-handed, or left-handed, and add the margin of error, and I apologize, that's in percentages. From the previous example, it's formatted, but it works for us here. Same thing with the right-handed. We're going to take our 60, and our margin of error is the same because our sample statistic, we have 100 people still. So we're going to do equals 60, subtract our margin of error, and then do 60 and add our margin of error. Oops. Go backwards. We need to select this one, equals our 60%, add our margin of error. There we go. And so we'll put this in here, and we go from 30 to 50, and from the right we go from 50 to 70. And double check how did we do and move to the next one.